Okay, we're looking at exercise 11D from the first year mechanics textbook. We're on question 11 and we've got an exam style question. So these can be quite helpful because they tell you how many marks each part's worth, so you can get an idea for how hard or how long it should take. Okay, so we're given the acceleration of particle p, so that's in terms of t. We're told that lowercase v is representing the velocity, and then we're given some information. We're given the initial velocity. Okay, so the first thing I'm asked is to find v in terms of t. So I'm given the acceleration and I'm after the velocity. That's going to involve integrating. So the velocity is the integral of t minus 3. Okay, so that was the acceleration. So t is going to integrate to t squared over 2. 3 is going to integrate to 3t, and there's going to be a plus c because I'm integrating, so don't forget that. So then it also tells me that when t is 0, v is 4. Let's make a note of that. So if I sub that in, so 4 is 0 squared over 2 minus 3 times 0 plus c. So c is 4. So velocity is t squared over 2 minus 3t plus 4. Okay, right there, and there's my answer for A. So that's v in terms of t. Then it wants the values of t when p is instantaneously at rest. Okay, so that's fine. So it's at rest when v is 0. Okay, oh, I'm sorry, I'm stepping ahead of myself there. I was just thinking I'll multiply 3 by 2. Right, okay. So you can put that into your calculator. I'm going to multiply 3 by 2 just to make it a bit easier to factorize. So that then does factorize, but you could put that into your calculator. That's absolutely fine, as long as we get those solutions. And yeah, so values of t. So I'm happy that I've got 2 solutions. It wasn't at rest to start with. It had a velocity of 4 to start with, so t is 0 shouldn't have been a solution. So I think we're fine. I'll just put s for seconds. Actually, they don't look like 5s. And then we're good to go. Okay, so and that actually probably 3 marks probably seems a little bit generous for that working, but obviously there's a mark for solving the quadratic, but there's also a mark for the interpretation. So just knowing what you need to do to answer that question. So obviously actually solving the quadratic is quite straightforward, but in applied maths, part of what they're testing you on is knowing what to apply to the situation they're describing. Okay, then I want the distance between the 2 points at which p is instantaneously at rest. So I know the 2 values of t now. I've got that from b. So if I'm now after distance, I'm going to find the displacement. So displacement is going to be the integral of velocity. And make sure you go back to the actual velocity, not the version I multiplied 3 by 2. So this was my velocity. Okay, so that's going to be t cubed, and I'm going to divide by 3. That's going to be t squared, and I'm going to divide by 2. And there's going to be a plus c, and they don't give me any information about its starting point, but that's okay because I'm actually going to sub in limits. So I'm not going to need to know what c is. Okay, so where I just need to be careful is, in fact, no, I'm absolutely fine here. So I don't have to sketch velocity. I am just going to do a quick sketch though, just to be clear about what's going on. So the velocity, so v is t squared over 2 minus 3t plus 4. So don't let that t squared over 2 put you off sketching it. We've got the roots. Yeah, the velocity is 0 at 2 and 4. I've got a y-intercept of 4. I know it's a positive t squared, so there's a very messy sketch of it. Okay, so I've got y-intercept of 4, and then I've got x-intercepts of 2 and 4. Okay, so I know that I'm going to get a negative answer when I find, so the displacement is going to be negative because I can see that area is below the t-axis. So that's absolutely fine. The reason I was just checking was if part of the area was positive and part of it was negative, then I would have to split it up. I think you had to do that in one of the previous questions. Can't can't remember the question number now, but if you've done everything up to question 11, you would have seen that come up in one of the earlier questions. Okay, but I'm fine. So basically, I want to integrate, well, in fact, so if I go back to this, I wanted to integrate between 4 and 2. So that's why, oh, why did that change that to 0? Right, so that's why I don't need to worry about plus c, because, oh, for goodness sake, oh no. Okay, right, I'm just going to ignore that. Okay, right, let me still see what I'm writing. I'll figure out what I've done in a second. Or not. I'll go away. Okay, brilliant. Phew. Didn't do the whole thing again. Okay, so, right, so I'm actually, so I've already done the integrating, so I'll go straight to my square brackets. So that was the integral. Okay, and I've now got limits of 4 and 2. And I know that that should give me a negative answer, and that's fine. So it's a negative displacement, but then they want the distance, so I'm just going to give that as a positive distance. So it's going to be 4 cubed over 6 minus 3 times 4 squared over 2 plus 4 times 4 minus 2 cubed over 6 minus 3 times 2 squared over 2 minus 4 times 2. Hoping I've written that down correctly. Okay, so I am expecting this to give me a negative answer. Assuming my sketch is correct. So minus 3 times 16 over 2 plus 16 minus 8 over 6 minus 12 over 2 minus 8. Okay, that's not giving me a negative answer, so I've typed something in wrong. Oh yeah, okay, so yeah, so that's one of the big benefits of doing the sketch, is I had a mistake there that I probably would not have noticed if, yeah, so when I had that mistake, I was actually getting a positive answer, which I knew couldn't be right, which I knew couldn't be right because I knew I was expecting a negative area. Okay, so probably find I've typed something else in wrong as well, but we'll check that in a second. So that's giving me negative 2/3. So that's a negative displacement. So the distance, I think, is 2/3 of a meter. I'm just going to check that though, because I did rush that last bit. No, that's cool. Okay, so and we'll just quickly check. Yeah, we've got 2 and 4, and we've got t squared minus 3t plus 4. Yeah, I think we're good.